Today we are going to cover section 7.4, matrix properties and operations. So take the time to copy your title and your essential question. How do you perform operations on matrices? Go ahead and pause it and we'll start once you're ready. Go and copy the cutout and copy example number 1. Pause it. Matrices. A matrix is denoted by an uppercase letter and elements are enclosed in brackets, such as the following, such as the ones given below. A dimension of a matrix m by n. So the dimension of a matrix is going to be two numbers where m times n are defined by the number of rows, which is the letter m, and the number of columns will be n. So therefore, this is the rows and that is the column. So for the first matrix, notice that's an uppercase letter A. We have how many rows? 1, 2, 3 rows. So therefore, this will be 3. And how many columns? 1, 2, 3. So therefore, this is a 3 by 3 matrix. Letter B, how many rows? 1, 2. And how many columns? 1, 2, 3 columns. And how about for the last one? What are the dimensions for matrix C? So this is 3 rows and 2 columns. So this is a 3 by 2. The entry ith row, so the letter I will be corresponding to the row, and the letter J will correspond to the column. Is denoted by the double subscript A sub ij. So therefore, this is A sub 2, 3, where the 2 corresponds to the row and the 3 corresponds to the column. So each of those components is going to have its own location, and that's denoted by the subscript. And lastly, two matrices are equal if the number of rows and the number of columns are the same and they contain the same elements. So they must be the same dimension, but they also must contain the same elements. So for example number 1, determine the value of x, y, and z. Since they are giving us two matrices, and this is a 2 rows and 2 columns, so this is a 2 by 2, and this is also a 2 by 2, and since they're equal, that means that the elements must be the same. So therefore, the value of x is 2. Then negative 2 will correspond to z plus 3. So we can just set up an equation. Negative 2 equal to z plus 3. So therefore the value of z will be equal to positive 5. Negative 3 is equal to negative 3 as it should be. And last, we have y is equal to 0. And therefore we found the values of x, y, and z. Example number 2. So take the time to copy it down and we'll start once you're ready. Go and pause it. So we can add the matrices. We can add two matrices only if they have the same dimensions. So in this case, they add in. This is what are the dimensions for the first one? 2 rows and 2 columns. So this is a 2 by 2. 2 rows and 2 columns. It's a 2 by 2. Since the dimensions are the same, then we can go ahead and add them. And our resulting matrix will be a 2 by 2. So it'll be negative 1 plus 1 gives me 0. I'm going to place a empty column, 2 plus 3 will give me 5. So it'll be easier to read. 0 plus -1 is -1, and 1 plus 2 will give me 3. So therefore, we're basically just adding the corresponding, the -1 with the 1. We're adding the 2 with the 3. We add the 0 with the -1. And lastly, we add the 1 with the 2. And that's why they need to have the same dimension. So try letter B and letter C, and we can check on software. Go and pause it. So for letter B, the dimensions for this first matrix is a 2 by 3, 2 rows and 3 columns. The second matrix is also a 2 by 3. So therefore, we are able to add them. 0 plus 0 is 0. 1 plus 0 is 1. -2 plus 0 is -2. 1 plus 0 is 1. 2 plus 0 is 2. And 3 plus 0 is 3. So this is called the zero matrix. So therefore, whenever you add a matrix to the zero matrix, you end up with the matrix itself. Correct? Makes sense. And letter C. This is a 3 by 3. And this was a 3 by 2. Since they have different dimensions, then not possible. Since the matrices have different dimensions. The dimensions must be the same in order to be able to add two matrices. Let's continue to example number 3. Take the time to copy it down, and then we'll start once you're ready. Go and pause it. So in this case, we are given matrices A and B. And notice that both of them, this is a 3 by 3. And this is also a 3 by 3. So both are 3 by 3s. And we need to be able to find 3a, negative b, and 3a minus b. So let's go and find 3a first. So we can multiply a matrix by a scalar. In this case will be 3. And let's go and write down the matrix A, 3 rows. So it will be 2, 2, and 4. -3, 0, and -1, 2, 1, and 2. And notice that I leave an empty column because as we go through the next few sections, this will be very useful to be able to just read them very quickly. So therefore, the matrix 3a equals, and let's go and copy it. 6 multiplied by 3 gives me 6. So I'm just going to multiply each of the components by 6, by 3. That gives me -9, 0, -3, 6, 3, and 6. Easy as that. And that is part A. Now let's go into part B. Part B, I need to be able to find -b. So I'm just going to multiply each of the components by negative. See what you get, and then we can compare our answers. Go ahead and pause it and finish part B. So this case that'll be 2, 0, 0, 1, -4, and 3, -1, 3, and 2. I'll multiply each of the components by negative. So I'll be -2, 0, 0, -1, +4, -3, 1, -3, and -2. And now we can work on part C. On part C, I need to be able to find 3a minus b. But we know that we can rewrite, right? We have 3a here, and we have -b here. So let's go and rewrite it as 3a plus negative b. And now we can use what we have already. So therefore 3a, 6, 6, 12, negative 9, 0, negative 3, 6, 3, 6, plus negative b. Remember that on your homework, you need to be able to see your process. So therefore, we have 3a minus b. It's going to be a 3 by 3. Since they both are 3 by 3s, we can add them, and our resultant will be 3 by 3. So it gives me 4, 6, 12, negative 10, 4, negative 6, 7, 0, and 4. And that will be your answer. Let's continue to, so we added them, we subtracted them, we multiplied by scalar, but now we're going to go into matrix multiplication. So take the time to copy your cutout or paste it, and we'll continue once you are ready. Go and pause it. Matrix multiplication. So we have a matrix A, that is a n by n, a matrix B, that's an n by p. The product of both matrices, if you multiply them together, will be a m by p matrix. So we have two matrices, A and B. In order to be able to multiply those two matrices, these two numbers should be equal. That's why they have an n on this matrix and an n on this matrix. So therefore they should be the same. Your resulting matrix, AB, will be dimensions of a 3 by 3. N by P. That will be your resultant matrix. So let's go through example number 4. Let's go and find the product. First, we want to make sure that we can multiply them out. So we need to write the dimensions for each one. This is a 3 rows and 2 columns, so therefore this is a 3 by 2. This is 2 rows and 2 columns, so therefore this is a 2 by 2. Those two numbers should be equal, and they are. So therefore we can multiply them, and your resulting matrix will be a 3 by 2. So let's go and place our equal sign. Let's go and leave some space. We need 3 rows, so I'm going to go 3 high. And the way that we multiply them, we're actually going to multiply the first row by the first column. And we're going to multiply the first number by the first number. So therefore it will be 2 times negative 3, and we're going to add. Now we're going to multiply the second number by the second number. 1 times negative 4. And now we are going to multiply. So we multiply the first row by the first column. Then we're going to continue with the first row by the second column. And we're going to multiply the first number by the first number is 2 times 2 plus the second number by the second number, 1 times 1. And now we're going to continue. Now we're going to continue with the second row with the first column. It's the second row in the first column, so it's going to go on the second row and on the first column. Now we don't write things this, we can if you want, but I prefer to just skip one step. So I'll multiply 4, the first number by the first number. 4 times negative 3 is negative 12 plus second number by the second number. 0 times negative 4 is 0. And now we're going to continue with the second row, but now the second column. So first number by the first number, 4 times 2 is 8. Second number times the second number will be plus. 0 times 1 is 0. And now the last one will be the third row by the first column. First number times the first number is negative 9, plus second number by the second number will be positive 8. And now we're going to continue with the third row, but now the third column. Excuse me, the second column. So it gives me 6, second number times second number, plus negative 2. And now we can just simplify. So therefore, AB will be equal to 3 rows in 2 columns. That gives me negative 6, and negative 4 is negative 10. 4 plus 1 is 5. Negative 12, 8, negative 1, and 4. And this is 3 rows in 2 columns, so this is a 3 by 2, just like we wanted it to be. Now your calculator also does matrix operations. So if you have a TI-84, if you have a TI-84CE, then we can do it 2 different ways. Or otherwise, if you have a TI-84 Plus with a CE, you just need to update your software. But let me show you both ways. First, if you notice right underneath math, underneath the x to the power of negative 1, you see the word matrix in blue. So I'll go second matrix, and I want to go into edit them first. So I'll press enter. Now it's asking for the dimension. This is a 3 by 2, and I'm just going to type in the numbers: 2, 1, 4, 0, 3, negative 2. So you want to get used to using your graphing calculators for matrices. And now I'm going to go back. I can quit, or I can just go back second matrix, and my matrix is there for the first one. Now let's go and change the second one. Edit. It's also, now it's a 2 by 2, so now it changes it. So it gives you negative 3, 2, negative 4, and 1. And now that I press enter on the last number, I'm going to go quit. And now let me go through my matrices just to make sure that they're there. So I'll go second matrix, I'm going to press number 1, and I'm going to press enter. And the first one's there. I'm going to do the same thing with the second one. Matrix, I'm going to go into the second one, B, and the matrix is right there. Now we're going to multiply them out. So I'm going to go matrix, first one, I'm going to press it times, matrix, second one, and now it's going to multiply it out. And if we did it correctly, it should match our numbers, and it does. So now at this point you're asking, why do we need to do it by hand if our calculator does it? Because we need to be able to understand what the calculator does and how he achieves it. So let's try example number 5. Oh, well, let's go back. Your TI-84C, or if you have the updated software from the TI-84 Plus, then you can go alpha, y, just the same way that we've been accessing the fraction bar. I can go on the matrix, and now I can just go in here, type in selected. It's a 3 by 2, which it is. Then I click OK, and I just type in as this one. Oh, don't press enter, dears. So let me go back second entry, and I need to edit it here. So don't press enter, press 1. So I prefer to do it the other way, but sometimes you can still do it this way. The other way, you have a little more opportunity to be able to fix things, where on this one you can't. Now times, now I go into matrix again, and now I say 2 by 2, so I'll go up. Once I select 2 by 2, I come back down, press enter, and I can type in the numbers. So whichever you prefer, I prefer to do it through the other method because I have a little more space to come back to them if I need to. But the answer should be exactly the same, and it is. If you have a Casio, your Casio will do the same thing. You just have to Google it or just email me, and I can set up a time that I can help you out, or I can help you out during the next class meeting. Example number 5. So take the time to copy it down and pause it, and we can work it out together. So the first matrix is 3 rows and 3 columns. So this is a 3 by 3. This matrix is 3 rows and 2 columns. So we first need to verify before we do any work to see if we can multiply them out. And because they have the same inside number, then we can. Our resultant matrix will be a 3 by 2. And now we can set up a problem. So now it'll be equals, and it's going to be 3. So let me just make it 3 high. And now we're going to multiply the first row by the first column. The first number gets multiplied by the first number, so it'll be negative 2 plus the second number by the second number, so it'll be plus 2. The third number by the third number, so it'll be negative 3. And now we're going to continue with the first row, but now the second column. 1 times 4 is 4. Second number by the second number is 0. Third number by the third number is 3. And now we're going to continue with the second row and the first column, then the second row and the second column. See what you get, and then we can check our answers. Go and pause it. You got it? So I'll be 5. Oh, what did I do? See, I'm not really messing up. So it's not 5. What is it? First number by the first number, so it'll be negative 10. Second number by the second number, so it'll be plus 0. Third number by the third number is negative 1. Then the first number by the first number is 20, 0, and plus 1. And now the last one, we're going to multiply the third row by the first column and the third row by the second column. First row is a third row in first column, so it's going to go on the third row, and the first column is going to go here. So it gives me a negative 4. Negative 1 and 1 is negative 1, and that gives me negative 4. Now, 2 times 4 is 8. That gives me plus 0, and that gives me plus 4. And now AB will be a 3 by 2. That gives me 0, that'll be negative 3. That gives me negative 11. That gives me negative 9. That gives me 7, 21, and 12. So now let's go and use a graphing calculator to check. And I prefer to use the matrix menu to be able to type it in because it gives me a little more opportunities to be able to fix it. You can use the other one as well. So I'll press enter, edit, 3 by 3. You want to get used to typing this on your graphing calculator because you'll be needed to know this in college and for the test. They'll look fine. I usually double check to make sure I typed it in correctly. Now I'll go back into the matrix and I'm going to go into the second one so I can type in the second one. The second one is a 3 by 2. So negative 2, 4, 1, 0, negative 1, and 1. I also find that this is a little faster to type. So that looks correct. So now I'm going to quit. I'm going to type in matrix A times matrix B. Press enter. And it should match, and it matches. So therefore that is correct. And this is a 3 by 2. So try the example number 6. See what you get, and then we can compare our answers. Go and pause it. So first, let's check. This is 3 rows in 2 columns. This is 3 rows in 3 columns. So therefore, our inside numbers should match, and they do not. So therefore, they cannot be multiplied. And even if you try, let's say we don't check it, correct? We'll notice that there's something going on, correct? Multiply the 3 by the 2, the -1 by the -3, and the 2 doesn't have anything to multiply. So therefore, matrices cannot be multiplied. Excellent. So at this point, you should get a matrix that is 1 by 2, 1 by 2. And this is a 2, correct? Do you guys notice that? So therefore, this is the cost. This will be for the women's team, and this is for the men's team. And now if I had done it on the graphing calculator, I took the time to be able to enter them, each one. So matrix 1, matrix B, there. If I multiply matrix A times matrix B, so now you can see, oh, right? We don't want to do EC, we want to do CE. So it'll be matrix B by matrix A. There you go. And that should give us the same number. So you can see how powerful this can be. Especially in computer science, you can program it to be able to multiply it for you in business applications. So let's go and just write down the costs for the women's team. Is $2,490, and for the men's team is $2,882. So this will conclude the lesson for today. Have a great day, and I'll see you guys next time.